All right, so a quick recap of yesterday's notes. This is the 10-3 theorem. So there were 4 of them. 10-6 was the congruent corresponding chords, which says in the same circle or in congruent circles, 2 minor arcs are congruent if and only if the corresponding chords are congruent. So in that one, if the chords, this is an if and only if, which means it works both directions. If the chords are congruent, then the arcs are congruent, and reverse, if the arcs are congruent, then the chords are congruent. So if I had AB, like segment AB marked as segment congruent to segment CD, then I can say that the arcs are congruent or vice versa. Then you had the perpendicular chords bisector theorem, which said that if a diameter of a chord is perpendicular to the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc, which means it cuts the chord into 2 congruent parts and its arc into 2 congruent parts. Then there was the converse to that said if one chord is the perpendicular bisector of another, then the first chord's the diameter. So if I have the right angle and I have the congruency marks on the chord, then I would know in this case SQ is the diameter. And then the last one that said the equidistant chords theorem, in the same circle or in congruent circles, chords are congruent if and only if they are equidistant from the center. And again, this is an if and only if, which means it works both ways. If the chords are equidistant from the center, then they are congruent. And if the chords are congruent, they are equidistant from the center. All right, then we get to the warm-up. So number 1, it says find the value of x in circle C and explain. What do I know about this diagram? What's happening here? Yep.
Being bisected.
How do you know it's being bisected?
Because it's on the dot in the middle, and there's a 90-degree angle.
The 90-degree angle. So the 90-degree, so because it's a diameter, that's the first thing. The second thing is it has to be perpendicular. Because those are happening, we know these are congruent. So 3x equals 5x minus 12. And then I would solve, subtract the 5x. Negative 2x equals negative 12. Divide both sides by negative 2. And x is 6. And when it says explain, you can either use the name of that theorem, which was the perpendicular chord bisector theorem, okay? Or you can say if the diameter is perpendicular to a chord, it bisects it. Okay, again, name perpendicular chord bisector theorem, or you can describe it. Questions on that one? 2, find the value of x in circle C and explain. So what's happening this time?
As you can see, there's 2 chords.
Yep. What's true about the positioning of those chords?
90 degrees perpendicular to the line.
And one more thing. They're 90 degrees, which shows true distance, right? But there's one more thing we need.
And the lines meet in the middle.
Sort of. Yeah. Jonathan.
They're both bisected by the radius.
Yeah. Yes, but that's not what this one is. It would be if I was looking for the 2 parts. They're equidistant from the center. So if they're equidistant from the center, which means it has to have the right angle and it has to be marked as congruent, then they're congruent. So 4x plus 2 equals 18. Subtract the 2. 4x equals 16. Divide by 4. And x equals 4. And again, explain. And this is the equidistant chord theorem, or if chords are equidistant from center, then they're congruent. Sure. I feel like most things in this section, they are equal to each other. Like when it out, set them equal to each other, right? We're not talking about, the only other thing would be like maybe if you've got the angle, so you're trying to prove it's 90 degrees. But other than that, the segments are really, most of them are equal to each other. All right, and 3 says determine whether RS is a diameter. So this is that case. So if that is, how would I know that RS is the diameter? What has to happen here? What two segments? So we're using these two, right? If those are congruent and what? And perpendicular, right? So perpendicular, we need it to be the perpendicular bisector. So we know it's the bisector already because TS equals VU, right? That part's done. How do I show that that's perpendicular? Yeah. Yeah, but not every isosceles triangle is a right triangle. Kumar. That's just going to prove they're congruent, right? But congruent triangles don't necessarily have to have right angles, right? One of the very first things you learned about angles that form a line. What's true about two angles that form a line? God bless you. God bless you. They have to equal 180. So if we use what we just talked about, which either one, you could use side, 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 because this would be your reflective side. Those make the triangles congruent, right? If the triangles are congruent, then all their corresponding parts are congruent. So RVT would have to equal RVU. And that's your CPCTC. If that's the case, and RST has to equal RVT. RVT plus RVU has to add up to 180, and that's because of the linear pair postulate, or the definition of a straight angle with the linear pair postulate. Now I know if they're equal and they add up to 180, that RVT and RVU equal 90 degrees, which then makes these congruent, because if a chord is the perpendicular bisector of another chord, then it's the diameter. So it wasn't like a very formal explain. It kind of just said explain why it is. But you could quickly turn this into a proof. Kumar. This exact one, no. But there will probably be a proof. You're going to get a proof in today's notes. Questions on any of those? Questions on homework from yesterday? Then we're diving right into 10-4. So 10-4 is inscribed angles and polygons. So we already learned about central angles, right? Central angles are equal to the measure of the arc, and the central angle has its vertex at the center. Today we're going to learn about inscribed angles. Inscribed angles are angles whose vertex is on the circle. The sides are chords of the circle. And the arc that lies between those two chords, two lines, two rays, two segments, they could be any of those things, is called the intercepted arc. So now we're talking inscribed angle instead of central, and intercepted arc. So 10th theorem in chapter 10 is called the measure of an inscribed angle theorem. And it just basically says the measure of the inscribed angle is 1/2 the measure of the intercepted arc. So while a central angle equals the same, the inscribed is 1/2. Think it's further away, so it would be smaller. As you get further from an arc, it's going to be smaller. So in this diagram, angle ABC is 1/2 arc AC. So if I have the arc and I want to get the angle, I cut it in half. If I'm going the other direction, if I have the angle and I want the arc, I'll double the angle. Anybody still coming down?
Nope.
Thank you. Theorem 1011, inscribed angles of a circle theorem, says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. Logically, this should make sense. If AB has a measure, arc AB, and angle 2 intercepts that arc, it would be half its measure. If angle 1 intercepts the same arc, it would also be half its measure. This just puts it all together. So again, if two inscribed angles intercept the same arc, then the angles are congruent. So for example, if this was like 70 degrees, both of these would be 35 because they'd both be 1/2 that arc. Questions on that one? All right, inscribed polygon and circumscribed circle. So just some vocab here. An inscribed polygon is a polygon with all of its vertices on the circle. So inscribed really means inside. Whatever's inside the circle with all of its vertices touching the actual circle is said to be inscribed. So for these are both inscribed. The polygon or the triangle is inscribed in the circle, and the quadrilateral is inscribed in the circle. And then the term we use to describe the circle is it's circumscribed. If it's on the outside, it's circumscribed. And we say it's circumscribed about the circle. About the polygon. So in these cases, the circle is the circumscribed and the triangle or the quadrilateral are inscribed, but that could also be reversed. Like I could also have
a triangle.
Well, I could also have the circle on the inside and the triangle on the outside. And in this case, we would say the circle is inscribed and the triangle is circumscribed. So inside, inscribed, outside, circumscribed. And the reason you learn that is this. Theorem 1012 says the inscribed right triangle theorem. And it says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of that circle. So if you think about just that part, like if you look at the diagram, it says if a right triangle is inscribed in a circle. So if I have a triangle, and it is a right triangle, if I wanted to find, if I didn't know this theorem, if I wanted to find the measure of this arc of AC, ABC is an inscribed angle, right? And if it's 90 degrees and it's inscribed, what's the length of the arc it intercepts? The measure of the arc.
Who knows?
Huh?
I don't know.
Twice that.
It's twice that. So if this is 90 degrees, then this is 180 degrees. And if that's 180 degrees and this chord goes end to end, I know it's the diameter. So you could have figured it out, like that's a two-step process, but you could have figured it out from what you know before. This just puts it into one step for you. This says if it's a right triangle, inscribed, so all the vertices have to be on the circle, then the hypotenuse of that is the diameter of the circle. And conversely, meaning switch the order, if one side of an inscribed triangle is the diameter, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. So you could use this in both directions. Either it is the right triangle, so its hypotenuse is the diameter, or the hypotenuse, or the diameter is a side of an inscribed triangle, and then you would know that triangle is a right triangle. Questions on that one? All right, and inscribed quadrilateral theorem. So quadrilateral being four sides. If we have a quadrilateral inscribed in a circle, then its opposite angles are supplementary. And this is an if and only if with means both directions. If it's inscribed in a circle, its opposite angles are supplementary. And if the opposite angles are supplementary, then it's inscribed in the circle. So if you've got four sides, it could be any shape. It could be a square. It could be a rectangle. Well, not really a rectangle. It could be, this case, it looks like it could be a parallelogram. It doesn't even have to. It just be a quadrilateral. And the opposite angles are going to be supplementary. So 1 plus 3 equals 180, and 2 plus 4 equals 180. And really, it comes from that all four of them have to add up to 360, right? So if they all have to add up to 360, and then I cut that in half, and they're going to make it 180 and 180. All right, an angle inscribed in a semicircle is always a right angle. So this basically comes from the one before the one we just did. If this is my, if it's inscribed in here, this has to be 90 degrees. It takes it a step further. You don't even have to know that that's the diameter yet, okay? As long as those 3 points are on my circle. And it's the semicircle. It's 1/2 the semicircle, which would be 90 degrees. So that one doesn't have a name. It's just an extension of the theorem. All right, now we just apply them all. Says find the values of x and y in circle O. So start with A. There's a lot going on here. Where can we start? If I want to find x, where do I start? Kala. Close. It's not a central angle. So what do I do with that 20? What's that? What?
By 2.
Good. That angle is an inscribed angle, right? So the angle is half the arc, or the arc would be double the angle.
How do you know which angle to choose?
You go end to end on the arc. So if you want to find y, like y is this whole angle, right? This is one side of the angle. This is the other side of the angle. So I have to do this plus that. Let me do a different color. I have to do from here all the way around to here, which is? So the arc is 150. What's the angle? 75, half the 150. Because it's the 110 plus the 40. So my advice on these, and I'll give you instruction when it comes to homework, but you are going to screenshot these pictures and you're going to draw on them. You're going to get used to drawing on them. Because especially like for the angles, I would do what I just did there where I extend the angle out to the circle so you know which one you're talking about. It gets really confusing to try to just stare at it and figure it out. All right, go to B. So X is this whole angle here, which would be half this arc. Do I know what that arc is yet? No. The only thing I have is the other side of the angle.
Yeah, you can get one arc, which is 40.
This is 20. Good. So that arc is 40 because it'd be double it. And then do I have X?
Yep.
X would be?
20 also.
20. Good. And then Y is this whole angle here. So that goes from end to end here to here. What's true about that angle? Or that triangle? The hypotenuse is, or the longest side is the diameter, which means that Y is what? 90 degrees. So if your angle is inscribed in the semicircle, which it is, or the triangle's opposite side is the diameter, it's a right triangle. Questions on those? Go to C. Tell me what you know.
All of them are equal
How do you know that?
because 60 degrees.
That doesn't mean that others have to be 60, right? If one more was 60, yes. Or if the sides were marked as congruent, yes.
I know at the bottom left angle is 70 degrees.
This one.
You're right.
This one would be 70 because it's half the 140. Good. What else?
So you just, or I know that x is 120, it's double 60.
Good. This would be the 60.
That's a fine one.
So this is 120. X is 120. And then how do you find y?
Subtract 130 from it because 70 is 60. So you know that.
Oh, okay. So both of those work. So you went triangle and then you're going to bring it out.
Yeah.
So the triangle,
That's 130. That's 50. Angles.
these together would be 130. That leaves 50 for here, which makes y 100. Or you could have gone arcs. I could have done 140 plus 120, 260, and then subtracted it from 360. So either of those work, and they should work, which is a good way to check your answer, too. Questions on that one? All right, go to the D. Tell me what you know. This should be a straight line. I know it's really not, but it should be a straight line. Yeah, these things are really hard to draw in PowerPoint, yeah.
X is 40.
X would be 40 because it's half the 80.
And I know that the side, like the angle opposite x on the other side is also 40 because those two lines that make up the angle are equal to each other.
And because
So
there's
yes.
marks.
Okay, so this would be a reflexive side, and those two triangles would actually be congruent because the side angle side? No. You don't have an angle yet. You don't have an angle yet.
Can't go to conclusions there. So I can see that there's two marks that shows that the sides are congruent.
Yes, these are congruent, which means what?
So it means that
If the chords are congruent, what's true about the arcs it intercepts?
they're
They're also
also.
congruent. So these are congruent, okay? Still doesn't help us with a measure though.
But then you have this 80 also, right?
Yeah. No, but how do you know that's 80?
Because they're congruent.
How do you know that?
Because the lines.
I think so.
What lines?
I think something is.
These.
Those lines tell you these are congruent.
But if.
You're missing
right,
something.
right.
Mars,
The reflective congruent lines puts in too.
still need more.
You know what the angle opposite of the diameter is 90 degrees.
These are both 90 degrees because this is a triangle inscribed, right, inside a diameter.
So they are the same.
So now they're the same. You are getting there, but you're just missing that step.
Basically, I was right.
Sure.
Basically.
But if that was a proof, you'd miss a step. Yeah.
Can you say that since that's the diameter there, that the other half is 100, which would mean that like the other side of that
This could be 100. Yep. Then you could go, this is 100.
it lies.
Then you could go that 80. Yep. And this is 50. So again, there's a couple different ways to eventually get there. With the right angles, you actually could prove the triangles are congruent because the hypotenuse leg, right? And then the rest would be congruent. But just by looking at it, you can't assume all that stuff. Like you can't assume it's going to always be congruent. Kumar. Because this is an angle, there's two ways. That's an angle in which the endpoints of that angle are the diameter, right? That's a theorem. Or this angle is inscribed in a semicircle, so it's half of 180, which is 90.
Are the illustrations of the quiz going to be slightly better? Because it throws me off a little.
It's a test, not a quiz.
Oh.
But if you're unsure about the accuracy of the diagram, you can always ask. Mm-hmm.
How do you get those two equivalent arcs of 100 degrees?
Because these chords were congruent. So if that's from yesterday's stuff. If the chords are congruent, then the arcs are congruent. And then this was the semicircle. This side is the semicircle. And there was already 80. So we took the 80 off and gave it 100. So then the 100 reflects on the other side, and then the 80.
Also, 50 plus 90.
Yeah, you could do that way.
What, 8?
Well, 50 plus 90.
I mean, 50 plus 40 plus 90 is what 8.
Where you get 50?
No, because you have the 90 plus
Oh,
40.
like if this was 50?
No, because you can get it from the 90 and 40 you have it. And then you get the sides 100.
You get the 50. You mean if you're doing 180 degrees inside the triangle? That's what you mean? Yeah.
Yes.
Yeah. Questions? All right, last one. We're back to our proofs. So it says given circle O is equal to circle P. Stop there, and what does that tell you? What does it tell you if two circles are congruent?
From the same size?
What does that mean? What's the same size?
Oh, diameter.
The diameter or the radius. So that's what you know from that. So if they're congruent, right, that's why they tell you that. If they're congruent, the radius or the diameter would be congruent. Okay, that's what it's telling you there. The second part says arc AC is equal to arc AB. So AC, which is here, is congruent to AB, which is there. And the goal is to prove those triangles are congruent. So 1 circle O equals circle P, and arc AC is equal to arc AB. Given. Now go back a couple chapters. What are the ways to prove triangles are congruent? Side, side, side. Side, angle, side. Angle, angle, side. Hypotenuse, leg. One more. We have angle, angle, side, butt. Angle,
Angle, side, side.
side, angle. Angle, side, side is not a way to prove the triangles are congruent. So if you just look already, obviously there's no information about a perpendicular side yet, right? But we might be able to get there because it's a semicircle. So we're not going to rule out hypotenuse leg yet, okay? What we don't know is all three side lengths, okay? So let's see where we can get there, because I'll tell you right now there's more than one way to do this. So give me a starting position. And why do you know that? So now we're talking segment, right?
Yeah, because it's I said that when arcs are equal, so are the chords are different.
Good. Okay, so I get lazy and I say congruent arcs have congruent chords. Okay, that's basically what that means. Now what?
Now we could say that angle D is equal to angle E, because we have the arcs.
Okay.
I mean the chords, sorry. Or no, the arcs.
Angle D is equal to angle E.
Yes.
And why?
Because
You're not wrong, but I want to hear you actually try to articulate that.
the arcs are congruent. So congruent arcs.
So inscribed angles
Yeah.
that intercept congruent arcs in congruent circles, because they have to be congruent circles or the same circle, are congruent. Okay.
DA equals AE because when circles are congruent, so are their diameter.
Good. DA equals AE. You can actually say definition of congruent circles.
No, it's a
Not yet.
side angle side.
You can't, because then this.
That's angle side side, which you can't use yet. You still need something else.
We have both sides.
You have two sides and the non-included angle, which is angle side side, which we have established is not a thing.
Can't we say
It's side angle.
How?
I mean, my hypotenuse is
Did you say that?
You're very close.
opposite to right angle.
So angle B is equal to angle C. Because the inscribed angle intercepts the diameter. Technically, I would have had to say that they're both 90, and then they're both congruent, so I would actually have probably said that's 2 steps, angle C equal, yeah, let me do that. Angle B equals 90, angle C equals 90. Then you can say angle B equals angle C. And that's substitution. Or I could have stopped there at the 90 and used what?
Wait, what number 5 is equals?
What?
Would angle be equals 90 degrees because inscribed angle is supposed to 90 degrees?
Yeah. But I don't even need this.
When you put for 4, it can't read.
It says definition of congruent circles. Once I have the right angle and I have the sides are congruent, what sides do you have are congruent?
That one.
You've got the hypotenuse and you've got
That leg.
a leg, which means ABD is congruent to ACE, hypotenuse leg. So we didn't need this one, not to say it's wrong, but we didn't need that one. Because really all you need is the right angle, the leg, and the hypotenuse. And that's not to say that's the only way to do it.
Is there a faster way?
Not really. It should have been 5 steps instead of 6. No. Yeah. But
Not my fault. Might have been Jonathan's.
Well, I was
Or
going a different
hers.
way.
Or hers. Oh, my bad. My fault.
questions. So again, remember that if you are trying to prove triangles are congruent, there are 5 methods: side, 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 side angle, side, angle, angle, side, hypotenuse, leg, and angle, side, angle. And you've got to work to get that information. So if it's anything about, like, obviously chords, it goes back to yesterday. So it's going to pull back that information. And then today would be about your inscribed angles or your inscribed polygons. Questions? Where the material for the test stops. To be honest, there's a bunch more sections and there's a bunch more stuff about circles. And some years we give a full chapter test. It's a lot of information. So we're cutting it here so you literally have half of that information, okay? We're not done with circles by any means, but we are done with the content for Friday's test. So I would say tomorrow we'll do it again kind of in class, but if you want to go back through and you want to summarize all your theorems up to this point, there's what, like 13? It probably is not the worst idea. This is a heavy vocab and heavy theorems, this chapter. But if you know them well, it shouldn't be too bad.